In this video, we are going to be learning about how to find limits from a graph. A limit is defined by the y value a function approaches, not necessarily equals, but approaches as it goes to an x value. So here's our limit notation. We abbreviate the word limit LIM. Down here, this means x approaches c, and then f of x is our function. So altogether, we read that as the limit as x approaches c of f of x. And we want to be careful that we note that the output, f of c, and the limit, as x approaches c, of f of x, those are not always equal to one another. All right, a couple more vocabulary terms before we get into some practice questions. So there are a couple different types of limits. There's a left-hand limit, a right-hand limit, and a general or two-sided limit. The left-hand limit is the limit as x approaches c from the left. And the way that we would note that is the limit notation x approaches c, but we're going to have a little negative symbol. It almost isn't like the exponent location of that c there, of f of x. Whereas when we talk about the right-hand limit, we're going to be approaching from the right, and you'll see a little positive symbol there. And the two-sided limit means we're considering both sides. So there is no symbol, it's just that notation from above. The limit is x approaches c of f of x. In order for the general limit to exist, the left-hand limit and the right-hand limit must be equal to one another. And when this happens, the left-hand limit, the right-hand limit, and the general limit are going to produce the same answer. All right, let's start with a relatively simple graph, something that we've seen many times before. So we have the graph of f of x equals x squared here, parabola. First, we want to find the limit as x approaches 2 from the left. So first, let's just note where 2 is. So I'm just going to zoom in on the picture for a second. Okay, here's 2. And you can see that it has an output of 4. But remember, the output and the limit are not always the same thing, just sometimes. So we're going to examine that here. So as we approach from the left, here's what that means. Watch how I'm going to start tracing in pink here. I'm going to look at the left of 2, and I'm going to start tracing, and I'm going along the graph, getting closer to x equals 2, and you can see that the y value that I'm approaching is 4, right? My pink line there, pink curve there is going towards 4. So the limit as x approaches 2 from the left is 4. What if I approached it from the right? So I'm going to zoom back in, I'll switch colors here, and now I'm going to start to the right of 2, and I'm going to trace the graph, and you can see that I'm once again approaching 4. So we want to know, does the limit as x approaches 2 of f of x exist? That's our general or two-sided limit, and my answer is going to be yes, because the left side limit and the right side limit are equal. And finally, for part D, we want to find the limit as x approaches 2, that general limit of f of x. That's simply just going to be 4 because we got the same answer for our left-hand and right-hand limits. So again, this is a pretty basic example. The graph is one we're comfortable with. It's continuous. And it's just a little bit simpler because we don't see any breaks in the graph. But what we're going to often look at when we look at our practice question today is something like this, where we have a piecewise graph. So a piecewise graph is made of different pieces, hence the name. And in this case, we have the piecewise function, f of x, and it's shown on the graph here. And we're going to use it to answer questions 1 through 18. So just some reminders as we go through here. Remember that a function must pass the vertical line test. That's why if I look, for instance, right in here, you can see that there's not 2 filled in circles there for those coordinates, just 1, because otherwise it would fail the vertical line test. So you're going to pay attention to the open circles and closed circles. All right, let's look at our examples here. Number 1 says, find the limit as x approaches -3 of f of x. Notice there's no left-hand or right-hand notation here, so we're going to look at both. So here's -3 on our graph. As we approach from the left, I'm approaching 5. As I approach from the right, I'm also approaching 5. And therefore, that means my general limit is simply 5. Number 2, the limit as x approaches 9 of f of x. Okay, so take a look at 9. As I'm approaching from the left, I'm going towards 2. Remember, I'm going, what y value am I getting close to? From the right, I'm going to 2. Therefore, our limit is 2. Number 3, the limit as x approaches negative 1 of f of x. I can see that I'm approaching the y value of 1 from the left, the y value of 1 from the right, and therefore my answer is 1. Now, all of those, notice at -3, 9, and -1, the x values that we were approaching in questions 1 through 3, the graph was continuous there. There were no breaks in the graph. We're going to start to see some different things going on in the next few problems. Okay? I'm just going to erase anything I had kind of bolded over in the picture here. All right, so when I look at number 4, it says the limit as x approaches 1 from the left of f of x. So let's look at 1. And as we approach from the left, notice what y value I'm approaching, and I'm approaching the y value of 5. Now, if it asks me what the output is, which we'll see in a minute, that's going to give us a different answer. All right, for number 5, the limit as x approaches 1 from the right. I am going to see that I'm getting 5 as my answer. And therefore, since the left side limit and the right side limit are equal, for number 6, the general limit is also 5. So here's the part I was mentioning before. Notice 7 does not have the limit notation. This is simply asking, what is f of 1? At 1, what is the output? And you can see that it's not 5 because of that open circle on the graph. Instead, down here, you're going to see that it's -8. So f of 1 is -8. So remember we said earlier in the video that, I'll scroll up and show you, to be careful that f of c and the limit as x approaches c of f of x are not always equal. This is an example of that. We found the limit, we found the output, but they are not equal to one another. All right, let's practice some more. I'm going to, again, just erase some markings on my graph. For number 8 and for number 9, we're approaching -5, but 8 is asking from the left and 9 is asking from the right. So let's find -5 on our graph here. As I approach from the left, okay, look to the left of -5 and kind of trace over it here, you can see that I'm approaching -2. However, when I go from the right, follow my pink tracing here, you can see I'm approaching -1. This is the first example we're looking at where the left and the right side limits are not equal. Okay, so for number 9, I'm going to say that this is -1. That would mean, by the way, that the two-sided limit at -5 does not exist. All right, number 10. The limit as x approaches 2 from the left, 11 is going to ask from the right, and 12 is going to ask for the two-sided limit. So let's go on our graph here, and I'm going to erase this, and let's look at 2. As I'm approaching from the left, I am going towards 10. Okay, notice I'm going towards the y value of 10. Whereas when I go from the right, I'm approaching the y value of -3. So our answers here are going to be 10. Oops, move that in the right spot. We're going to have 10 and -3. Therefore, since those answers do not match the limit as x approaches 2 of f of x, we're going to say D and E does not exist. All right, number 13, 14, and 15 are all asking about what's happening at -9. Okay, so let's find -9 on our graph. All right, as I'm approaching from the left, you'll notice something different here. There's nothing, right? There's no function for me to trace over. So that means that that limit does not exist because I don't even have anything to look at there. When I go from the right, however, That's this pink piece here that I'm going to remark. I have a limit of -2. So the limit as x approaches -9 from the left, that does not exist. -9 from the right was -2. Those answers don't match, right? So the two-sided limit, we are going to say, does not exist. And finally, for our last 3 examples here, we're going to be looking at x approaches 3 from the left, the right, and the two-sided limit. Okay, so let's find 3 on our graph. Okay, I'm going to erase some markings that I have already. As I go from the left, I'm approaching -3. And as I'm going from the right, I'm approaching 8. So my left-hand limit is -3. My right-hand limit is 8. And since those two do not match, we are going to say our general or two-sided limit does not exist. Hopefully this video helped you learn a little bit more about how to find limits from a graph. Other videos in this playlist will go over how to find limits from tables, by direct substitution, and by algebraic manipulation. Thanks for watching.